So we are going to analyze and graph piecewise functions today, and the first thing we're going to do is talk about the appropriate viewing windows on a graphing calculator. Alright, so this is going to be a multiple choice question. So when you're graphing, this is going to be your X scale and then your Y scale. Okay? Alright, so quick refresher, you're going to go to Y equals and then X to the 4th minus 2X squared plus 20. Okay, so then you're going to click on your window. So the first one's negative 10 to 10. This X scale just means you want it to go by 1s, 2s. Okay, so we're going to keep it at the 1s. And then when we graph it, okay, for the first one, can you even see anything? No. Okay, so we're just going to write for there that you had no graph. Okay, it was a blank graph there. Alright, so now we're going to shorten up the X scale. And then this is 0 to 15. Okay, so again we have the blank graph. No graph. So this was a blank 10 by 10. This was a blank 0 to 15. Alright, so now we're going to go negative 2 to 2. So we're making the x's even smaller, and then we're going to go to 18 to 28. All right. That looks pretty good. All right, so we have like this saw curve here. These are going up on both sides. Okay, and then this one you have the same x's, but now you're going from negative 100 to 100. So here you have like this U-ish shape, okay? That's because you're only looking at part of this graph, alright? And then you have to choose the best one. So the best window in this case that would give us the best picture is which? C. Okay, so that's going to give us the best picture of the graph. Alright, now we're going to talk about piecewise functions. So, for many of you, this is a review. For others of us, this might be new. We're going to sketch the graph by first identifying the type of function. Now, this is something that you can really just do in your head. I like to go over this to remind you that, hey, if you just have f of x equals 1. We'll write f of x. I want you to practice doing that. So if you have f of x equals 1, that's a constant function. So that's just going to be a horizontal line. So you're only going to be graphing part of it, the part for x is less than or equal to 1. And then what type of function is f of x equals x plus 1? Linear. Right? And then you just want to look and see, is the slope positive or negative? Because if it's positive, it's going up from left to right. If it's negative, it'll be going down. Now, when you make your table, you're really going to be making 2 mini tables, and you want to make sure you include points in each interval. We're going to be labeling them as open or closed. So you have 2 functions. You have the f of x equals 1, and then the f of x equals x plus 1. So the quickest way to make your tables is to look here. If x is less than or equal to 1, I always start with 1. These are going to be our key values. Now, this says x is less than 1. So I'm just going to pick some other values that are less than 1, like 0 and negative 1. As long as they're less than, it doesn't matter. Okay? And then because this isn't equal to, this is a closed circle. So I really just write the closed circle. This is our first time through, so I'm going to try to slow it down a little bit. And then we talked about this yesterday. If you plug in 1, but there's nowhere to plug it in, what's your answer? What's your y? 1. Okay, so no matter what your x value is, your y should be 1. Okay? Alright, and then for this one, we are also going to start at 1. And I know some of you might be wondering why. We're going to talk about that, okay? So we're going to start at 1 because that's our key value, and then its x is greater than 1, so we can do 2, 3. You can keep going. You just really only need a few points to help you see what's happening. And then we're going to plug in x to get our y. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and now we have a series of points. Now because this is just greater than, that means we're going to have an open circle here. So when I graph this point, this is going to be an open circle, okay? Alright, so the first part, you have 1, 1. So at 1, 1, we need a closed circle. Okay? At 0, 1, you're here. At negative 1, you're here. We already talked about how this is going to be a straight line. Okay? And then you're going to put your arrow on it only to the left, because this is only for x is less than or equal to 1. Okay? This is your value of 1 at x. Now here I have 1, 2. So at 1, 2 I have an open circle, and then at 2, 3 it's just a point. At 3, 4 it's just a point. Okay, so again you're going to put your arrow on there. The only place you have the open circle is the key values. You don't make these open because then there would be a bunch of holes there. That's not accurate. The only place that's not included is the 1. So the reason why you have to include this value is so you can put the open circle, because if I just started at 2, see how I would be missing this part of the graph if I started at 2? You have to include everything going up to 1. Because really, how many points are in between 1 and 2? Yeah, an infinite amount. Okay, so you have to make sure you have that on there. Alright, and then make sure that you know, write a little note, okay, in piecewise functions, what should those lines never do?
Cross.
Yeah, they'll never cross, they'll never overlap. So in piecewise functions, the lines will never overlap, and that's because they're on different intervals. Okay, if they're in different intervals, they're not going to overlap. Okay? Alright, so I feel like this is something that we did last year in Algebra 2. Okay, for B, we're going to pick it up a few notches. So, again, remember, the first thing I like to do is make sure I understand what type of function it is. So, this one's linear. What is the second one? Quadratic. And this one's linear, okay? So this has a positive slope, it should be going up from left to right. This has a negative slope, so it should be going down from left to right. And then with the quadratic, how do you know if it opens up or down? Which one? So yeah, so some in positive or negative? No. Okay, yeah, so if the coefficient of x squared is negative, it's going to open down. And look, here's your x squared, that's negative, so this is going to be opening downward, okay? So we're going to be graphing pieces of each one of those. Okay, so we have 4 equations. That means we're going to have 4 tables, or 3 equations, so we're going to have 3 tables. There's going to be mini tables, so 3 values each. The value in front of x squared is negative, so it'll open down. If the value in front of x squared is positive, it'll open up. Alright, so let's put our key values on there. So for this one, it's going to be 0. And then, like I said, I just put a closed circle there to remind me, because I like to do all my tables at one time. Okay, and then I just have to pick values that are less than or equal to 0. So I just put a couple in there. Now for this one, it's 0 to 2. So I have to start at 0, end at 2. This is going to be an open circle. This one is going to be a closed circle. And then I'll just do 1 because it's in between it. And then the last one is x is greater than 2. So I can do 2, 3, 4. That will be an open circle. Okay, so I'm going to give you a minute to fill in the table for each one. Okay, and then you guys can start graphing those after you plug them in. So you should get 4, 3, 2. And then here, when you plug in 0, you get 4, 3, 0. Okay, and then remember, when you plug this in here, it's negative 2 plus 4, negative 3 plus 4, negative 4 plus 4. Now, I'm not sure if you guys remember this last year, but if you have a point where there's an open circle and a closed circle, do you remember what you have to do? Make it what? Yeah, make it a closed circle. Don't make a target. Okay, so if an open and closed circle overlap, keep it closed. Okay, so don't make a target. Okay, and then Adam, did you have a question for me about the table part?
Yeah.
So this will also, if they're not a key value, it'll always be closed. It'll just be a point. So it'll always be a closed point. So for 0, 4, I'm right here, and that's a closed one. Okay, and then I have negative 1, 3. I'm just going to put a point. Negative 2, 2. I'm just not going to make it as pronounced, okay? And I will let you guys use straight edges for your graphs so that you can span the entire graph without necessarily having to do that. Okay, so this is the first part of it. Alright, now we just talked about this. If at 0, 4 there's an open circle, I don't want to see any target practice, no target symbols, you just keep it closed. Okay, and then you're at 1, 3, and then you're at 2, 0, and this is a closed one. Now keep in mind, okay, keep in mind for this one, this should be a quadratic, which means when you connect these, it's going to have a curve to it. Yes. Okay, so there's going to be a slight curve for this one. Because it's a quadratic, that's part of a parabola that's opening down. Okay? And now I'm at 2, 2, so that's an open circle. And then I'm at 3, 1, closed circle, and then 4, 0, and then so we're just going to connect those points, and that is a straight line. Like that. Connor and Brayden, do you guys have a question for me? You don't have any questions about the piecewise?
No. Well, that's what we are.
We're wondering if we had to use this in the
Oh, yeah, for the straight line. You can. I like it. It makes it look nice. Okay, and then we're gonna go back to the graphing calculator for example 3. And you are going to be given a family of functions. and you are going to graph all the members of the family in the viewing rectangle. We're just going to draw a rough sketch of those graphs, and then for part C, we're going to state the conclusion. Okay, so in parts A and B, we're going to graph all the family members. We'll draw a rough sketch, and then we'll state the conclusion. Okay, so this is your function family, so they're all going to be part of the quadratic family here. Okay, so if C was 0, you would just have x squared. If C was 1, you'd have x minus 1 squared. Alright, so now I want you to graph that on your graphing calculator. Alright, so we're gonna graph this whole family. So we have x squared, we have x minus 1 squared, and really we talked about what happens last year. Do any of you know already without graphing it what's going to happen? We talked about what this transformation is going to be, right? Where are the graphs going to move?
The translation.
Yep, where?
To the right.
Did you graph it? Yeah, would you remember why it's to the right and not to the left? It's the x minus h. Yep, and then so it's going to go there. So let's see what we got. Oh, and then your window's probably still in your window before. So let's go and let's switch it. So you can see this window right here is not good, the last one we were on. So we're going to go -5 to 5. And then -10, you can just delete that other 0. Alright.
Wait, what was the y scale? Yeah, wait, what was
Right here, -10 to 10. Alright. And so for x squared, we are right here at the origin. Right? Then we have the x minus 1. So where is the x-intercept for that one? Where's the x-intercept for this one? 1. Then you have the x-intercept for 2. Then you have it for 3. Doesn't that look beautiful? Alright, now if they're negative, when you plug them in here, the x minus is going to become what? Plus. So we're going to be graphing x squared, x plus 1 squared. I do feel that we are intelligent enough where we could actually predict where these are going to go. So if these all shifted to the right, for B, they're all shifting where? Yep, to the left. Okay, so again, you have the x squared at the center. And then it's going to move to your -1. Moves to -2. And then your -3. Okay, so how does the value of C affect the graph in this case? Okay, so we're stating the conclusion. So if all the graphs shifted to the right, and in B they all shifted left, okay, we can say for part A, as the value of C becomes larger the further to the right the graph shifts. Okay. Now, in part B, what's happening to the value of C? In part B, what's happening to your C values? As the C values decrease, the graph shifts. It's running out. I'm going to say further left. Okay, so you just analyze whatever your findings are. Alright, now there's a special type of piecewise function. It's called a step function because it's going to look like a pair of floating stairs here. Okay, so we're going to go over a situation that's going to produce a step model. So the domestic postage rate of first class letters that are weighing 3.5 ounces or less is 44 cents for the first ounce or less, okay, plus 17 cents for each additional ounce, okay, and that includes a part of an ounce. So when you're trying to figure out costs based on weight, remember, you can have decimals within that value. Okay, and then what we have to do is express the postage as a piecewise defined function of the weight x of a letter with 0 being less than x being less than 3.5. And then what we're going to do is we're going to sketch a graph of this function. Okay. Alright, so the first thing we're going to do is we're going to define the p of x. And we are going to put this in brackets, but it's going to be large, so give yourself some room. Okay? So it says that it's 44 cents for the first ounce or less. So the way that we could write that is 44 cents, like this, if it's for the first ounce or less, that means it's going to be in between 0 and 1. Okay? It's not include 0 because there's going to be some type of weight to it. Right? If you weren't mailing anything, then you'd pay $0. Okay, and then an additional 17 cents for each additional ounce. So if this goes up to 1, then your next interval is going to be from 1. It's not going to include it. It's going to go up to 2 because the 1 is included here. So how can I figure out what this is going to be? So maybe we need some time to think about that. Okay, do I need to keep going here? How do I know what my x value is going to go up to? Do they tell you in the problem? Yeah, you're talking about this part. It would be what? Yeah, what did you say? 0.44. And then what else? Yes, so 17 cents for an additional ounce, right? So we can just add them together. So 61 cents. Okay, do I have to go to the next ounce? Yep, because it says it's going up to 3.5. Okay, so this would be between 2 and up to 3. So So again, you would just do what with the 61 cents? Plus 17. Okay, now because this says up to 3.5, your next one is just going to be 3 up to 3.5. You don't have to go to the 4 because you're stopping here. Okay? And again, you would just add 17 cents. Which is going to be how many? What's 78 plus 17? Okay, so now we're going to graph this. So when you're graphing, keep in mind what your labels are. So your X value is going to be your weight. Okay, and that's measured in ounces. Okay, and then your Y value or your P of X is going to be the cost. Okay, and really I should have given you a grid for this. I will give you graph paper for your homework, so it's your cost in dollars. Okay, so for the ounces, we just have to go up to your 3.5 or 4. However you space these out, you want to try to be consistent. Okay, and then for the change, because you're dealing with cents, I would just go up by 20 cents and then we'll estimate. This would be 20, 40, 60, 80, $1. Okay, so when we're plotting these, the first one is 44 cents, and then see how you have 0 here? So at 0, it's 44. Okay, so about halfway would be 50. That's about halfway here, so that one's going to be an estimate. So you have an open circle, and then it's going to go to 1, which is a closed circle, and this is a constant rate. So that's going to be the first part of the function. Okay, the next part of the function's at 61 cents, and so I'm going to have an open circle at 61. Okay, so 161, and then that's going to go until 2, which will be a closed circle, and that's going to be your second step. And then I'm at 78 cents. Okay, and then your last stair is only going part way, so just remember that that one's going to be a little bit shorter. So that's 95 cents, so you have an open circle, and then you're just going to 3.5 here. So it's going to be half your other stairs. Alright, and then there's your little floating staircase.